Hello everyone, myself Mounika. I'm working as an assistant professor in Mlritm from the Department of CSE Data Science. So today we're gonna discuss about finance algorithm and candidate elimination algorithm. So these are the topics which we'll cover in this session. So first, what is finance algorithm and what is the algorithm for this? And we'll see the example. And next we'll see the candidate elimination algorithm, next algorithm for that and example, and we'll see the advantages over the CE and like we'll see the advantages of candidate elimination algorithm over finance algorithm. So first we'll see what is finance algorithm. So as a name indicate, we'll find out the specific hypothesis for a particular problem. So the finance algorithm is one of the earliest and the simplest algorithm in the concept learning, and it is designed to find the most specific hypothesis, and that is consistent with all the positive training examples in the data set. So we'll take a data set to train the concept learning, right? So in that we'll consider only positive examples for this finance algorithm, and this algorithm begins with the most specific hypothesis with no value is acceptable, which is denoted by pi, and gradually generalize it whenever it encounters a positive example. And we'll have some representation for this algorithm. So first, the question mark. The question mark indicates that any value is acceptable for the attribute. So we'll consider the initial hypothesis as a null hypothesis in the first step. And next, we'll specify the single value required for the attribute. So we'll consider each attribute as a single value. And next, that pi indicates no value is acceptable. And next, the more general hypothesis for this finance algorithm would be all the question marks. And next, the most specific hypothesis will get represented by all the pi's. Next, what are the different kinds of steps which will get involved in finance algorithm? So we'll start with the most specific hypothesis, that is, like we'll consider all the pi's as the first initial hypothesis for this algorithm. So in the first step, we'll take the next example, and if it is negative, then no changes occur to the hypothesis. So we have a data set. We'll take one data set. In that we'll consider only positive example. So if we found any kind of negative example, so we'll do any changes. And next, if the example is positive, we find out our initial hypothesis is too specific, that we update our current hypothesis to a general condition. So whenever we encounter with any kind of positive data set, then we'll change the current hypothesis to a general hypothesis. And in the next step, keep repeating the until above steps till all the training examples are complete. So we'll have a data set of a combination of positive example at the same time negative example. So we will consider these steps 1 and 2 till the last example. After we have completed all the training example, we'll have the final hypothesis when we use it to classify the new examples. So we'll see the example. So this is one kind of data set which will be used to check whether the seed is poisonous or not. So these are the attributes here. So color is one attribute, toughness and fungus and appearance and the poisonous. So these are the attributes for this data set, and one is example 1, example 2, example 3, 4, 5, 6, 7. So these are the 7 examples were taken for this calculation, and here we have taken some positive examples. So here S is mentioned as a positive example, and here we have 2 negative examples. So for the finance algorithm, we'll use only positive examples, and each example comes with one attribute value, as we have discussed earlier. So color. So for in the first example, the color for the seed is green, and the toughness will be hard, and the fungus will be no, and the appearance will be wrinkled, and it is poisonous. So these are the example set 1, and these are the attribute values for that. Next we'll see the example here. So first, initially we'll take the first initial hypothesis as all the null hypothesis. So we'll consider the first example first. So as we have taken this as a first hypothesis, right? So this is the example one, green, hard, no wrinkle. So we have taken 4 attributes here. So we'll compare it with the initial hypothesis so that we'll get a hypothesis of again. So this green is replaced with the pi. So we'll get green. Again, hard is getting replaced with the pi. Again, we'll get hard. And no is replaced with the question mark pi again, and so wrinkled. So this is the first hypothesis we got from the example 1. Again we'll consider the example 2 here. So here we'll compare the first example. So for in the first example we have considered the initial hypothesis with the first data set, that is first example. So we have compared and we got one hypothesis here, and now we are comparing the example 2 with the example 1 hypothesis here. So this is the example 2 have green. So we'll see the example set. So here we have green, hard, S, smooth here. So green and green are same, so no change is required. Hard and same, so no change is required. So here we have a no to S. So here we got a difference. So we'll make it as a question mark here. Again, wrinkle and smooth are different. Again, we'll place a question mark here. So we'll consider the example. So here in the example we have a poisonousness as no. So we'll consider the same. So we'll never change these values, and this never affect the hypothesis. Why? Because here we got a concept called no here. Okay. So we'll consider only positive example. So in the second hypothesis there will be no change. So here we'll keep the same hypothesis. So green is green, hard is hard, no is no, and wrinkled is wrinkled. We'll keep the same hypothesis when it compared with the second example. Why? Because it has a concept called a negative. Next we'll take the example 3. So here 3 again has a no as a concept. So here we'll never consider the third example again, and we'll keep the same hypothesis for. So green will be kept here, hard, no wrinkle. The same hypothesis will get received in the third example also. Again, now we'll compare the fourth example. So in the fourth example we have a concept called S. So we'll compare the example 1 with example 4 directly here. So here the fourth example data set will be orange, hard, no wrinkle. So this will get compared with the previous hypothesis, that is green, hard, no wrinkle. So here the fourth example is orange. Orange is getting compared with green. So here these two are different colors. So we'll get question mark. Hard is same. So we'll keep same. And here we have fungus as no. We'll keep the same. And wrinkle is same. So we'll keep the same. So the one question mark will get here. So the final output, the final hypothesis after comparing first example with the fourth example will be question mark, hard, no wrinkle. Okay. And next we'll consider the example 5. So again example 5 comes with the positive. So we'll compare again. So again we got here question mark. So here question mark is getting compared with the green. So we'll keep green here. And hard is off. Question mark again. No S. Question mark again. Wrinkle is smooth and question mark again. So here we got we are getting two different attribute values, so that we'll never keep the same value here. So we'll mark a question mark here. So when it compared with the fifth example, the final output will be question mark, question mark, question mark, question mark. So this is how we got our final hypothesis with the help of find-S algorithm. And since we have reached a point where all the attributes in our hypothesis have the general condition, and example 6 and 7 would result in the same hypothesis, all the general attributes. So this is how we'll compare each and every example, and we'll only take positive examples for this find-S algorithm. So this is all about, and this will be the final hypothesis for this data set. Next we'll see the candidate elimination algorithm. So here the candidate elimination algorithm is incrementally builds the version space given a hypothesis space H and a set of E example, and these examples are added one by one, and each example is possibly shrinks the version space by removing the hypotheses that are inconsistent with the example. And the candidate elimination algorithm does this by updating the general and specific boundary for each new example. So here the shrinking of version space can be done. Okay, so here you can consider this an extend form of the find-S algorithm. So we have a disadvantage with the find-S algorithm, as we take only positive examples for the find-S algorithm. So to improve the quality, we have here the candidate elimination algorithm will use both the positive and negative examples. So here that point is mentioned here, and actually the positive examples are used here as a find-S algorithm saying, and while the negative example is specified in the generalized form. Okay, so we have some terms here. So concept learning, the concept learning is basically the learning task of the mission, and general hypothesis. So we have two terms here, general hypothesis and a specific hypothesis. So in the general hypothesis, not specifying the features to learn the mission. So we'll just mention the hypothesis with the number of attributes, and the specific hypothesis will specify the features to learn the mission. And every time the specific hypothesis will get marked with the pi symbol, and again the number of pi will depend on the number of attributes again, and the version space. So it is an intermediate of general hypothesis and specific hypothesis, and it is not only just write one hypothesis, but a set of all the possible hypotheses based on a training data set. And next, algorithm for the candidate elimination algorithm. So we'll see. First, in the first step, we'll load the data set, and in the second step, we'll initialize the general hypothesis and the specific hypothesis as we have discussed earlier. So general hypothesis will get initialized with all the question mark, and the specific hypothesis will get represented with all the pi's. And next, step 3. So this can be done for each training example. In the step 4, so we have two different kinds of examples. So we'll consider positive examples and negative examples for this candidate elimination algorithm. So we have two different conditions for the positive example and the negative example. So first, if the example is positive, if the attribute value is double equal to hypothesis value and will not doing that nothing, and else will replace the attribute with the question mark. So this is same like find-S algorithm. So when we are comparing with the example 1 and 2, will compare the same will compare the attributes of two different examples. If the two attribute values are same, we'll keep the same attribute value. If two attribute values are different, then we'll make it with the question mark. Okay, and if the example is negative, then we'll make the generalizations to more specific. So this is the example taken for the candidate elimination algorithm. So again same. So these are the list of attributes here. So like we'll find out the sky, and we'll find out the temperature, humidity, wind, water, forest, and output. So this is the positive example, positive, and this is the negative example. Okay, so for the candidate elimination algorithm, we'll consider both the example. So for the example 1, we have taken sky as a sunny, temperature as a warm, humidity as a normal, wind as a strong, water as a warm, forest as a same, and the final output will be S. So this is how we took 4 examples. So we'll see the algorithm steps here. So initially we'll initialize two things. First one will be general hypothesis, and the second one will be specific hypothesis. So in the general hypothesis, we will divide the number of attributes into different sets here. So when we are comparing 6 attributes, so we'll divide into 6 different sets with the 6 attribute values. Okay, and specific hypothesis comes with the 6 attributes same. It will depend upon the number of attributes again. So for the instance 1, so like we have taken first a positive example. Okay, so the general, so positive example, right? So this is a positive output. So we'll do the same fineness algorithm steps here. So here the first hypothesis will be sunny, warm, normal, strong, warm, same. So this will get compared with the null hypothesis. So null will get replaced with the sunny, again null with replaced with the warm, and null with replaced with the normal, null is replaced with the strong, null is replaced with warm, and null is replaced with same. So here all the null attributes will get replaced with the example 1. Okay, and next for example 2. So the example 2 will consisting of warm, high, strong, warm, same, and this is also a positive example. So here for the example 2, we have taken again positive example. So we'll keep the general hypothesis as same, and we'll do the comparison with the first example and the second example. So so first attribute sunny is getting compared with sunny, so say we'll keep the same. Warm is getting compared with the warm, so we'll keep the warm. And normal is getting compared with the high, so we have two different values, so we'll keep the question mark here. Again, strong is getting compared with the strong, warm is getting compared with warm, same. So these are the three same attributes we have. So we'll keep all the three attributes same like this. So this is the second hypothesis we got from the second example. Again for the example 3. So example 3, we have a negative example. Okay, so in this we'll do the general hypothesis. So the general hypothesis would be, so here we got a general hypothesis here like sunny, warm, strong, warm, space, same. So we'll write in a different way. So the third example will be rainy, cold, high, strong, warm, chain. Okay. So here it comes with the negative example, right? So here we'll compare this with the second specific hypothesis, that's sunny, warm, strong, warm, same. So here we'll keep the similar values. So sunny will keep the, so sunny will keep same, and warm will keep same. Again we have a question mark, so we'll mark the question mark as same, and the last, so strong will be keep same. So again we'll make a question mark, and the last will keep the same. Okay, so this is how we'll get our general hypothesis. And for instance 4, so instance 4 again comes with the positive example, and we'll keep compare it with the previous example output. So here sun is getting compared with the, so sunny is getting compared with this specific hypothesis, sunny, warm, strong, warm, same. So here sunny, so we have a same sunny, again warm, again question mark. So question mark, we got say a different hypothesis here, and a strong will keep the strong, and the last one will be same. So here we have a different hypothesis, same and change are different. So we'll, and the last will mark it as a question mark, and this is a output we got from the instant 4. So the general hypothesis for this, so we got sunny, warm, and for the specific we got as a sunny, warm, and strong. So this is the output we got from the candidate elimination algorithm. The difference between the fineness and the candidate algorithm will be, so here in the fineness we'll compare only positive example, and we'll do the calculation like we'll compare each attribute value. When the both attribute values are same, we'll keep the same attribute value. If it is different, then we'll place it with the question mark. So in this candidate elimination algorithm also we'll do the same step for the positive example, and for the negative example we'll do the specification that is specific hypothesis. So here we have advantages of candidate elimination algorithm when it compared with the fineness. So the first advantage would be improved accuracy. So the candidate elimination algorithm considers both positive and negative example to generate the hypothesis, so which can be result in higher accuracy dealing with noisy or incomplete data. So when we are comparing both the examples, so we'll get the accuracy output here. And the flexibility, the candidate elimination algorithm can handle more complex classification tasks such as those with the multiple classes or the nonlinear branch decision boundaries. And the third will be more efficient. So the CEA reduces the number of hypotheses by generating the set of general hypotheses, then eliminating them by one, and this can result in a faster processing and improving efficiency. And the last, better handling of continuous attributes. So this will handle continuous attributes by creating the boundaries for each attribute, which makes it more suitable for a wider range of data sets. And these are the some references for this find this algorithm and the candidate elimination algorithms. Thank you.